Welcome to all of you. In this lecture, we are going to discuss about the program status word of 8051 microcontroller. The program status word is a 8-bit register. It can store the information about the program as well as it monitor its status. Program status word is also known as the flag register of 8051. Now let us go through that 8-bit register and which are all the flags available in that program status word. Now this is the bit 0 and this is the bit 7 we are having. Starting from the bit 0, the first one is the P, that is the parity flag. The next one is not defined. OV is the overflow flag, and RS0 and RS1, both of these two are register bank select bits in combination. F0 is the user flag and AC stands for auxiliary carry flag and CY is the carry flag. Now let us take each of them individually and let us verify how they are going to set and reset based on various operations. First, let us start with the parity flag. If A register in the sense it's the accumulator, contains odd number of ones, then P is equal to 1, else P is equal to 0. Now let us consider an example for that. Let us have the value 0, 1, 0, 1, then 0, 1, 0, 0. In this case, we can identify there are 3 ones. 3 ones in the sense odd number of ones. So number of ones is equal to 3. Therefore, in this case, parity flag will be set equal to 1. Consider one more example. So 0, 1, 1, 0, 0, 1, 1, 0. In this case, we can observe there are 4 ones. So number of ones is equal to 4. It is an even value. Therefore, in this case, parity flag will be set equal to 0. Right? So now let us get into the next one. Now the overflow flag. So first let us understand when it is going to set and when it is going to reset. So the overflow flag, it is set to 1 if there is a carry out from the bit position 7 but not from bit position 6. That means in this case carry flag will be equal to 1. So or if there is a carry out of the bit position 6 but not from the bit position 7. Right? If either of these two conditions satisfies, then the overflow flag will be set equal to 1. So in very simple manner, if we say the logically overflow flag is the carry out generated from the position 6 and XORed with the carry out generated from the bit position 7 is what the overflow flag. If its outcome is equal to 1 means the overflow flag will be set. If its outcome is equal to 0 means the overflow flag will be equal to 0. So overflow flag basically used with the signed operations in order to detect errors. So signed operations, then we have to identify first what is the range of operation. The range of signed operation will be always minus 128 to plus 127. So let us write it as 2 only. Okay, plus 127 we are going to have. If any value is going beyond this range, then overflow flag will be set equal to 1. So that always follows this concept. Let us consider an example for this one. Let us consider the addition of two numbers. One is plus 60 in hexadecimal, whose equivalent binary value will be equal to 0, 1, 1, 0, 0, 0, 0, 0. Then plus 46 we are going to consider. So it is going to have equivalent representation 0, 1, 0, 0, 0, 1, 1, 0. Now let us add these two values. we are going to get, here it is 0, then 0 1 it is 1, 0 1 1, 0 plus 0 it is 0, then here it is 0, then here it is 1, 1 1 it is 0, carry is generated over here, then addition of this is 1, so here no carry is generated, so I will write it as 0. Right, now as per the representation what we have taken over here, so in this case this 1 XORed with this value is going to generate the output 1, which is same as the value of the overflow flag. Right, now what is this value? This is equal to plus A6. Right, so plus A6, if we convert that to the decimal value, then it is going to be value 166 decimal. Right, and this 166 is greater than this 127. Correct, that means whatever the signed operation range is there, the answer is beyond that range. Therefore in this case overflow flag must be set equal to 1, and also as per the procedure what we have discussed, from that also if we verify, overflow flag will be set equal to 1. Now let us consider one more example where overflow flag will be set equal to 0. So first let us take out this one, and then I will take the second one. So we'll take the second example for this one. So in the second example, let us consider the two values where both of them are negative. So I'm going to consider -2 in hexadecimal we can consider. So that will be equal, in 2's complement it is being represented as 1111 1110. Remember, this is its 2's complement. Minus 5h, it is given by 1111 1011. Now add these two, it is, here it is 1, then 110 carry, 110, there's a carry, here it is 1 and 1 carry, and again 1 and a carry, 1 and a carry, and 1 and a carry, 1 and a carry over here. Right, and this value is equal to -7h. Right, so now verify, this -7h is within the range of -128. So in this case overflow flag will be equal to 0. In the another sense, if you verify, see the carry out generated by the 6th position to the 7th position, it is 1. Then from bit position 7 to the next one, it is again 1. XOR between these two values again gives the value 0. Right, so it is satisfying both the criteria what we have discussed. Hence this overflow flag in this case is equal to 0. Right, now let us get into the next case, that is RS1 and RS0. So both of these two are used in order to select the register banks. So totally we are having 4 register banks. Power on reset will always select the register bank 0. So power on reset always gives us with the register bank 0. Instead, if we want to consider any other banks in order to store the values, then we have to change the values of RS1 and RS0 as per our requirement. Then those particular register bank will be selected. And remember, in all the register banks it will be R0 to R7 only representation. Based on the values of RS1 and RS0, it is going to identify from which register bank it is addressing. If RS1 and RS0 are 00, then register bank 0 is selected. If it is 01, then bank 1 is selected. If it is 1 0, then bank 2 is selected. If it is 1 1, then bank 3 is selected. This can be done by making use of the bit level operation, right? The bit values of RS1 and RS0 is known, that is bit position 4 applicable for RS1, bit position 3 applicable for RS0. For example, if I want to select the bank 2, then what I have to do? RS0 must be equal to 0, RS1 must be equal to 1. So I can say set bit SETB, the position we have to mention of program status word dot 4, right? So bit 4 of the program status word will be set equal to 1, that is nothing but RS1 is equal to 1, and I need to clear the bit position PSW dot 3. So now bit position 3 in the sense that is corresponding to the RS0. So I set RS0 is equal to 0, then RS1 is equal to 1. So register bank 2, now it is selected. So like this we can select any of the required banks by using bit level operations. Now let us get into the auxiliary carry flag. It will be set to 1 if there is a carry out of the bit position 3, 0 otherwise. Now let us consider an example for this one. Consider the addition of two numbers, and I will consider the numbers like 1 0 0 0, 1 0 1 0. One more number I am going to consider 0 0 1 0, 1 0 0 0. Add these two. Here it is 0 1, then 0 1 1, it is 0, carry is generated, then 1, then 1 0 1, right? So this is bit position 3, and this is bit position 4. What the statement says, if there is a carry generation from bit position 3 to bit position 4, then auxiliary carry flag will be set equal to 1. In the another way we can say, if there is a carry generation from lower nibble to the upper nibble, then the auxiliary carry flag will be set, but this is what the exact statement to be mentioned, and in this particular case the auxiliary carry flag will be set equal to 1. Consider one more example for this. 1 0 0 0, 0 1 0 0, 0 1 0 0, then 1 1 0 0. Add these two. So here it is 0 0, 1 1 0, it is 1. So again carry is generated. Let's 0, and here it is 1, and again 1 here, 0 and 1 here, and 1 here, right? So in this case again if you make a verification, then from bit position 3 to the bit position 4, carry generated. Again in this case also the auxiliary carry flag will be set equal to 1. Take one more similar example, and I will just make a little bit variation over here itself. Instead of taking it as 1, I will just make this value equal to 0. Now take the verification. So it is 0 0 1 1 0, carry generated here, and it is 1, and it is 0 0 1 1. So from bit position 3 to 4 no carry is being generated. Therefore in this particular case auxiliary carry flag will be set equal to 0, right? So this is what auxiliary carry flag. Now let us get into the carry flag. Carry flag will be set to 1. Carry flag will be set to 1 if there is a carry out of the bit position 7. Otherwise it will be equal to 0, Right? Now let us consider an example of addition of two values. So two values. So 1 0 0 0 1 0 0 0. Then second value I will be taking 1 0 1 1 0 1 1 0 I am taking. Add these two values. So 0 0 it is 0, then 1 1 1. So here 1 1 0 1 1 it is 0. A carry is generated and that will be stored here. Right? So this is bit position 0 and this is bit position 7. Now from the bit position 7 a carry has been generated here. Right? So in such case carry flag will be set equal to 1. Take one more example. So 0 1 0 0 0 1 0 0. Then I will take 0 0 1 1 1 0 1 0 I will be taking. Add these two values. So here it is 0 1 1 1, then 1 1, and again here it is 1 and here it is 0. So from this bit to the next one, so no carry is being generated, so carry not generated. In such a case we consider carry flag will be equal to 0. Right? Now let us get into the last flag. So that is in the bit position 5 we have one more flag that is called F0. So F0 we say it's a user defined flag. That means it is not specified internally for which operation it has to alter. Instead user can set or clear this flag based on whatever the requirement he or she wants. Right? So now user can make use of this bit. This can be set by using the instruction set PSW.5. So that's the fifth bit. Or it can be cleared by making use of the instruction PSW CLR PSW.5. So both of these two are bit level instructions. So this is all about the program status word of 8051 microcontroller. Thanks for joining.